Hello, everybody. Today we will be talking about factorials, and this is part of the Algebra 2 curriculum. Factorial is basically kind of like a stepping stone for higher mathematics. You'll see a lot of it used in calculus and also in statistics. So this is basically just kind of like an introduction. So we're just going to make sure that you understand how factorial actually works, so then that way you can do the hardest stuff in the future. So if we're going to take the factorial, here's what I'm talking about. So a factorial notation would be something like this. We have 5, and then you see an exclamation part. This means 5. The way you say it is this is equal to 5 factorial. And what it represents, or what it equals to numerically, is 5 times 4 times 3 times 2 times 1. So numerically, you just go ahead and put that in your calculator if you want, and that would then be equal to 120. By the way, most, if not all calculators, scientific calculators anyways, should have a factorial key, so it would be nice for you guys to be able to find it before you start doing some of the work then that you have to do. So another example, maybe if I have like say 6 factorial, then that would be equal to 6 times 5 times 4 times 3 times 2 times 1. And that is going to be then, after multiplying everything out, 720. So that is basically just the general idea behind it. Now, for factorials, if you notice what's happening, the key thing you have to remember is that you actually cannot take the factorial of certain numbers. So if I say n factorial, we got to make sure that n cannot be less than 0. In addition to that, n cannot be equal to a non-integer number. Okay, so non-integer value. And you're thinking, okay, well, in that case, according to the first one, then technically we can have, in fact, 0 factorial. And the answer is yes, and we'll see how to derive that in just a little bit, okay? So let me just kind of hold that on the side. 0 factorial, what is that going to be equal to? Let's go ahead and maybe do a few more examples of this before we go ahead and derive it. Actually, if anything, we want to make sure you understand some of the properties too. So let's say that we have this time 3 plus 2 in parentheses factorial. Now, there are two ways of looking at it. One is the order of operation, which is the correct way of looking at it, meaning that we deal with what's inside the parentheses. So that'll be equal to 5 and then factorial. So the answer is equal to 720. A common mistake that I see a lot of people doing is that they'll say, oh, this is a parenthesis, so therefore I can go ahead and use the distributive property, so I can write it as 3 factorial plus 2 factorial, because you figure that the factorial looks like a variable, so that's why you can distribute. And unfortunately, this then leads to the wrong answer, because 3 factorial, that's 3 times 2 times 1, plus 2 factorial, that's 2 times 1. You can see then the answer is going to be 6 plus 2, which is equal to 8. And these two right here, they are not going to be equivalent to each other. Oh, actually, right there, I made a mistake right there. It's supposed to be 120. So how about that? So yeah, all that stuff in the past, order of operation, this still applies. So we got to be careful about that. Let's see. Let's go ahead and move up a little bit then, do something a little bit more advanced. Suppose I want to solve for 20 factorial divided by 18 factorial. Now, yes, you can actually put 20 factorial in your calculator and 18 factorial in your calculator, and then, solve for each one and divide through. But I'd like to see if there's like a more finesse way of approaching this. So here, what I'll do is I'll go ahead and write out 20 factorials, so then that way we get an idea. So it's 20 times 19 times 18 times 17 times so on and so on, so on, all the way to 3 times 2 times 1. Now, 18 factorial, you can do exactly the same thing. You're going to get 18 times 17 times 16, and so on, all the way to the last three terms, 3 times 2 times 1. And as soon as you write out these terms and the general pattern, you should be able to see what's actually happening here. The 18s in this case would cancel out with both top and bottom. So will the 17, so will the 16, and so on and so on, so on, and all the way to the last terms. So that means whatever's left over, well, that's really just the first term and the second term. So this is going to give you then 20 multiplied by 19 So the answer is equal to 380. Remember, ideally, I would like to try to avoid using the calculator as much as possible because, well, math is not always about using a calculator. So yeah, that's my reasoning for it anyways. Here, let's try something similar to this, but with a little bit more variables. Let's say this time, let's say this time, we have the following then. N plus 2 quantity factorial divided by n factorial. Now, this one is a little bit harder to see, but I think we can use the same idea over here. Assuming that n, okay, and again, assuming that n is an integer, okay, we can then write out the following. N plus 2 factorial, the first term is going to be just n plus 2. The term after that, or before that in a way, is going to be then n plus 1 because it's 1 less than the previous term. Then 1 less than n plus 1, that's going to be n. Then 1 less than n will be n minus 1, and then n minus 2, and n minus 3, and so on, and so on, and so on. For the bottom part, you can see I can write that the same way. That's going to be equal to n times n minus 1 times n minus 2 times n minus 3, and so on, and so on, and so on. So in the same manner as the problem above, we can see now that some of these factors will actually cancel out. The n's will cancel out, n minus 1, n minus 2, n minus 3, and so on, so on, so on. So then now all that's left is just the n plus 2 multiplied by the n plus 1. And there you go. In this example that I just showed over here, I think we can kind of come up with a very important theorem that we can actually use to help us solve for 0 factorial. Suppose we have, again, let's use a numerical example to make it a little bit easier. 7 factorial. Well, that's 7 times 6 times 5 times 4 times 3 times 2 times 1. If you look at it carefully, you can see that a certain part of it, you can actually treat that as its own factorial. So in this case, for example, I can write it instead of 7 times 6 times 5 times 4 times 3 times 2 times 1, I can write it as 7 multiplied by 6 factorial. Similarly, if I have, let's say, maybe 11 factorial, then I can write that as 11 times 10 times 9 and so on all the way to 3 times 2 times 1. And then in the same way as we showed it right above it, you can see that this part right here that I just circled, that's the same thing as 10 factorial. So then I can write 11 factorial as 11 multiplied by 10 factorial. The conclusion I'm trying to get you to understand is that, well, according to what we just did, then if I have n factorial, that is going to be equal to n times n minus 1 factorial then. And that is actually what we can use to derive what we want. Now, let's see. Let's go ahead and use now this theorem, I guess, that we just came up with to do the following. Let's go ahead and let n equal to 2. Okay, so that doesn't sound too bad, right? So then that means we're going to get 2 factorial is equal to 2 times 1 factorial. And yeah, that definitely is equal, that is true because 1 factorial is equal to 1. 2 is just itself, so it does work out. Now, let me go ahead and move down by 1 degree. So then let's say this time let n is equal to 1. And watch what happens over here. If I take this n is equal to 1 and substitute it into this thing that I just came up with, this will now read the following. 1 factorial is equal to 1 multiplied by 1 minus 1 factorial. And that right there is where we're going to solve for our answer. 1 factorial, we can solve for that. That's equal to 1. Oops, sorry. Let me just go ahead and move down a little bit more. 1 factorial is equal to 1 times 1 minus 1 factorial, just kind of rewriting it. 1 factorial, that right there is equal to 1 because it's just itself. Is equal to 1 multiplied by, now 1 minus 1, that is supposed to be 0, and that's where the 0 factorial is coming from. Well, if the left-hand side is equal to 1, the right-hand side has a factor of 1, then that means that 0 factorial is equal to 1 then. And that is going to be something that's going to be very useful in the future then. Okay. All right, so I think that'll do it for now.